Alright, back to magnetism, and I think I fixed the problem. I'm pretty sure. Anyway, so it's always more complicated than I would like, but you know, that's the way it works. So I don't know if you can see this. I wish it was a little darker, but it is what it is. So anyway, I don't know why I don't know why I just didn't do north and south poles. I don't know why. I don't know why I have this. I have some sort of brain thing that just seems to think that magnets have to have four sides. I don't know why I do that. But anyway, it doesn't matter. The real point is that what I'm basically going to explain is why magnetism is so much stronger than gravity. So that's the catching point in the last video. And in the last video also I was describing the photons as two different kinds, A and B, and I really should have thought of it like light polarization. They're not just this and this. They come in the whole range of that circle. So I've made the gravity green. So it to represent what would be, 100%, vertical versus 100% horizontal. So that range would fill this 100% of light would be in either one of these two positions, somewhere between them. And that's where 100% of unpolarized gravity would exist in that state. And the catch with a magnet is that the more consistent the polarization is with the arrangement of the magnet's pole, the more likely there is to be an exchange of directional information, a push. So it's more likely to push the closer something is to its probably exactly the opposite pole, but we'll just say for the sake of argument, the more polarized the light, the more consistent with the pole's arrangement, the more likely that when the graviton comes in that it'll interact and exchange directional information or otherwise push and go off in its own direction. So the more likely there is to be a kinetic interaction in the subatomic structure that will create the change in the matter that will be arranging it to have a velocity in a direction of the net force of the interaction. It gets a little complicated to say this the right way, the right technical jargon without getting too technical. So anyway, so just the screen stuff is just a mixture, and so the more blue it would be, the more reactive red would be, and the more red it would be, the less reactive red would be. But the catch to magnets is whatever comes in, it all comes out this one polarization. So like a polarizing filter, it's essentially, we could say it blocks everything else, or we could just say it corrects everything to the correct polarization. So if something is in this angle coming in, it will be corrected to this angle going out. So when it exchanges, it comes in this way, exchanges some directional information, it'll be converted. And whether it exchanges or not, it will be converted. And the real catch with the exchange inside the matter, so to explain how magnetism essentially magnifies gravitons, their effectiveness. So you can sort of see it with this color change. The idea is that the red pole is creating gravitons that are invisible to the blue pole. So just think of the polarization of the thing would be the same as the polarization of the thing. So the graviton's polarization would be the same as this substance polarization, which means it would have no effect. It would go right through it. And the same with the blue would be the same as the blue would go right through it, which means there would be no pressure here, and you have all this external pressure here, so the two magnets would push together. The opposite effect would be the blues are creating the reds. The reds are hostile to the blue, so the blues would be pushing these two magnets apart because they have the same. They're getting 100% of the thing they're 100% sensitive to. So that's the change. The gravitons come in mixed with a variety of influenceability on the matter, and they leave with a 100% influenceability or a 0% influenceability. So all of the gravity is essentially converted into something that's 100% likely to create a directional exchange or 0% likely to create a directional change. So it's very much like light polarization in that sense. So anyway, so the description I'll give of common matter, just to sort of give an example, would be that, like, say common matter had a bunch of atoms in the way, and each interaction changed polarization, but each atom could be a plus or a minus randomly in terms of how it was polarized. So the graviton would come in and it would be polarized by an exchange with this atom to be the opposite. So it comes in at, let's say, a 40-degree angle, it leaves at a 60-degree angle, it hits this one, it goes to a 30, this one it goes to a 20, or if we say that it's going to flip them all the way, you could say that it went from 100, and all the way, let's say it went from all the way up, and then it came down all the way down, and then it went back all the way up, and then it came all the way down. All that would matter is how it left. It would be either all the way up or all the way down. So what's happening in regular matter is there's this, it just keeps reconverting, and in that and so there's no gain to the conversion. There's no substance or meaning to it. Whereas if all of these are pluses, if they're all aligned in the same direction, then it will be changed and it will go right through all these others. So that kind of creates the idea of the transparency. It'll just go right through them because they're all going to be, it'll be corrected by the first interaction and go right through. And likewise, if it's in the wrong direction, it'll be stopped by the first interaction. It's more likely to get stopped, and if it misses the first one, it'll hit the next one and the next one and the next one, because even if they're scattered, even if it's like a picket fence it has to go through, it's more likely to hit the next row of picket fences if it's still going the wrong way. That's not a great way to explain it, but so it's just this idea of recognizing that all these gravitons are 0 to 100% polarized in a direction. So this is 100% and this is 0, and so they're all in some variety of that configuration. And then when they leave, they're 100% this or 100% that. And that's what magnifies the effect of the gravitons on each other. So it's essentially changing this, changing gravity that would only be reactive, a tiny percentage of the time would it be 100%. So it would always be a degraded reaction potential. So it takes something from being, maybe a 2% probability of interaction with the matter to a 35% chance of interaction, but essentially 100% once it goes through the filter. It just depends on how much it's being filtered. I can't say that all of it is being changed. Like I said, it might be like light, where the percentage would be anything from 45 degrees up would be corrected to the vertical position. But one could say if the alignment was pretty consistent inside of a lattice of matter, that there could be all kinds of subtle variations that would keep correcting till it got perfect. That's probably unnecessary to even go there. Yeah, probably. So anyway, so that's the magnification. So I really, I needed that magnification thing, because obviously magnets are a lot stronger than regular gravity, and so I had to come up with some reason why. How does it get magnified? And this is a much better explanation. So there's no such thing as A gravity and B gravity. There's gravity that's somewhere on a scale between A and B. It's either polarized or, it's either this or this. Where before I was assuming it to be just two kinds. It comes in all of those varieties in nature. And magnets polarize it. And then they affect each other by exposing each other to the polarization that is the opposite of their sensitivity with attraction, and the same as their sensitivity for repulsion. So they do in fact magnify gravity. Yeah. So anyway, I like it. I mean, I think it explains the problem in the previous video. So, good enough, I think. Right? Yeah, it's good enough. Good enough for now. We'll move on to some other. See, this is the other thing, you know, there is so much to go over here, and each aspect, each subject, velocity, time, they all have a lot of nuance and complexity, and you know, so it's a lot for you know, one me to do. But anyway, I keep working at it. So I think the next video I'll just make some kind of proposition that I would, you know, just give fair warning. I don't know. But, well, you know, I'll just make the video. But you know, this idea of paying somebody to make a critical, you know, a professional critique, which you might call, you know, the word they what's the stupid word they use for when some magazine says what you're doing is reasonable, peer review. So I'll go seek this peer review and pay for it if I must. So I'll put like $1,000 reward to any college professor or any publication. You know, let's say the publication has to have at least a 50,000 circulation or something, or even a YouTube channel that has, you know, 200,000 subscribers. Yeah, I would pay a scientific YouTube channel that has 200,000 subscribers. I'll pay them to critically analyze what I've done so far and express an opinion on the viability and on any obvious flaws. Yeah. So anyway, I'll make a video on that. Yeah. So I'll have some kind of, yeah, $1,000 prize in the title or whatever. But anyway, there. So now you know what the next video will be. Maybe. I might have to fix magnetism again, but no, I think this does it. Green, blue, red. Yeah, it does it. 3 colors.